All right. We are going to continue with the blood discussion. And we started out yesterday and talked about erythrocytes, which are red cells, shortage of which is anemia, either not enough red blood cells or not enough hemoglobin, key part of which is iron. Abnormal increase in red blood cells that can be indicative of cancer if it's long-term exposure to high altitude or low oxygen concentration. That could be a not harmful cause of that. Leukocytes then, or white blood cells, defense, function and body defense. A couple of things about that: an increase in the number in response to infection is just fairly normal, but excess production without really kind of inexplicably, you might say, might be leukemia. And very inordinately high numbers of white cells would indicate leukemia. Couple of categories: granulocytes and agranulocytes. And those categories, as it says here, coming up on page 301. So this is the page you need to look at to kind of follow along with as you look at those characteristics. So the granulocytes include neutrophils and eosinophils and basophils, and the nuclei are lobed. And I think if you look on that picture, you'll recognize that. Agranulocytes, they're called agranulocytes because you don't see any granules in the kind of cytoplasm, and then the nuclei are not lobed. Lymphocytes and monocytes. Okay, platelets are those small pieces, chunks, kind of irregular pieces that they're involved in clotting. Okay, now the next thing that we're going to talk about then, if you turn ahead to page 302, is hematopoiesis. And hematopoiesis is the production of blood cells. And there's some kind of interesting information here with regard to what we might call stem cells. So they're undifferentiated cells that can become different things. And you can see that in the diagram on page 302. And I have it on here so you can look at it with me. Okay. All of them come from something called a hemocytoblast. Okay. And blasts mean cells that give rise to something, and they're building. If you remember from back with the skeletal system, we said osteoblasts are bone building cells. Clasts break down and blasts build up. So hemocytoblasts are stem cells in the myeloid tissue of the red bone marrow. And two types of descendants it shows: hemocytoblasts can become lymphoid cells and myeloid cells. So lymphoid produce lymphocytes, and myeloid get differentiated into, as you can see in the diagram on 302, or I'll put it up again here in a moment, but red cells and platelets and monocytes and neutrophils and eosinophils and basophils all come from myeloid tissue. I recognize I'm going to move through this a little bit more quickly, so you'll have to pause if I move on before you're finished writing. But hopefully you'll take the time to not just write, but listen to my 2 cents as far as that goes. Hopefully I can help explain a little bit of this. So here is that differentiation. So here's the undifferentiated stem cell that gives rise to blood cells, hemocytoblast, and lymphoid. So that becomes lymphocytes, And then myeloid becomes red cells, and then we have platelets and monocytes, and then the 3 granulocytes: eosinophils, basophils, and neutrophils. Right. So red blood cells. Red blood cells last 3 to 4 months, so you're continually replacing your red cells. The developing cells will divide many times. Then they begin to form hemoglobin. And hemoglobin is that critical substance that actually does the work of carrying oxygen, hooking onto and carrying oxygen. And a reticulocyte forms when the hemoglobin-filled cell ejects the nucleus. It still has endoplasmic reticulum, but remember, those mature red cells are anucleate. They do not have a nucleus. And those then enter the bloodstream, and then they fully develop into erythrocytes or red cells within a couple of days. And I don't know all the details of what it takes from that immature reticulocyte to a mature erythrocyte, but anyway, so that's when it can start carrying oxygen. Rate of production is controlled by erythropoietin, which is formed in the kidneys, and that process is shown on page 303. So that diagram and the balance, the teeter-totter seesaw thing, is showing how it's a homeostatic process, and so the normal blood oxygen levels, it's level. Decreased red count, decreased availability of oxygen to the blood, or increased demands for oxygen. So if you look at this, if you look at this part, if you look at that part, that's where we'd get the idea that if you were to live in high altitude for an extended period of time, that's how you could end up with an increased number of red blood cells, because you're consistently in in an environment that has a lower concentration of oxygen, just a lower concentration of air all the way around, but of oxygen, and therefore you could increase the red cells. And then, of course, that continues to balance as you have an increased oxygen carrying capacity with an increased number of red cells. Then there's going to be, it's going to shut off that triggering of erythropoietin. Leukocyte production is stimulated by colony stimulating factors. And we're not going to talk too much more about that. While you're finishing writing, I'll read you a little passage. Those colony stimulating factors not only prompt red bone marrow to turn out leukocytes, but also enhance the ability of mature leukocytes to protect the body. Apparently, they're released in response to specific chemical signals in the environment, such as inflammatory chemicals. So something that's causing an irritation. Additionally, exposure to certain bacteria or their toxins stimulate macrophages and lymphocytes. Okay. And then platelet production is stimulated by something called thrombopoietin. And there's a bit of a there's a bit of an explanation on page 304 of how that all plays in, and takes part in repairing blood vessels or injury. And that's, we said that platelets are involved in clotting, and that's explained a little bit further going forward here. Okay, so that's called hemostasis. And there are a couple of parts of that, 3 parts of that. a platelet plug is formed, and then there are vascular spasms, meaning that the vessel is kind of flexing, and then coagulation, which is that kind of a clumping up, and that's on page 304, shows that clotting. Okay, now when we talked about in biology, we talked about the genetic condition hemophilia, and that's where your blood does not properly clot, and so sometimes it's referred to as bleeder's disease. And I think it's actually a number of conditions that all have kind of the same symptoms, but anyway, disorders of hemostasis. With regard to clotting, a thrombus is a clot that develops in an unbroken vessel. So now we haven't had those triggering mechanisms of an injury that would normally cause your blood to clot, but now it's just clotting for no reason, potentially. And that, of course, is dangerous, particularly if it becomes an embolus and moves through the circulatory system and can cause a blockage at critical places in your circulation. The cause of clotting disorders, the vessel lining becomes rough, so that can make it more likely that you would have one of these sort of uncalled for clots. Injury, deposits, buildup of plaque in your vessels. So slow blood flow, blood pooling in immobilized patients. And that's something that you may or may not be aware of, but if someone is immobilized, perhaps because of some kind of a surgery or something like that, one of the major concerns that healthcare people have is that they don't get one of these clots, because they're not moving. And one of the things that helps blood move along in our vessels, of course, our heart is the prime mover pumping our blood, but there's something called muscle milking and all that kind of thing that helps facilitate the movement of blood through our system. Okay, so bleeding disorders, then platelet or clotting factor deficiency. So you have both. You have where either way it's bad. If it's clotting when it shouldn't, that's bad. And if it's not clotting when it should, that's also bad. Caused by platelet or clotting factor deficiency. Thrombocytopenia would be low platelets. The penia part, the low. Hemophilia, hereditary disorders, that's what I referenced earlier, the lack of clotting factors. And then you can have, can be caused from liver impairment or not enough vitamin K. Okay. I'm going to go back now. And again, if I realize I'm going through these more quickly than you can write, so just pause it and finish writing. But I'm going to go back to a couple of these videos that it referenced earlier. So here's. Okay, again, that it would probably be helpful if you had your book open to page 302 right now, as they're going through this. So the hemocytoblast is the least differentiated stem cell that gives rise to all the other blood cells. What do you call that breakdown of what makes up blood? It's called the hematocrit. Hematocrit. Okay. We're going to look at the next video. There was another one here about clotting. We'll take a look at that. Hopefully this link is functional. Sometimes they're it's the platelet plug. Okay. Obviously a sample video, so I had the thing over the top. I apologize for that, but the explanation was good there. Okay. Now, the next topic then is blood groups, and I'll probably move through this a little bit more quickly than I do some things because hopefully there's some familiarity. I think we talked about this to some degree, at least when you were a sophomore. So hopefully it a lot of this is familiar to you. So what we're really talking about is what's on the outside of the red cells, and they will cause an agglutination or an agglutination reaction when they're recognized as foreign by the antibodies in your body. There are over 30 different types of antigens, but we really only talk about three. There are A and B, okay? And someone might say, well, what about O? Well, O means you don't have A or B, okay? So um, if this is a antigen, so my fist represents a red cell. It just has this one thing sticking out. That would be type A blood. And let's say that this is B antigen. Well, if it looked like this, it would be type B blood. Okay, but if it was type O blood, it would just be this. There wouldn't be either of those things sticking out. And then separately, we inherit an Rh factor. And Rh positive means you have Rh antigen, and Rh negative means you don't have Rh antigen. So I know this is an oversimplification, but this would be O negative. Okay, doesn't have any of those things. It's just a red cell with none of those things. Now, to be clear, there are 30 different antigens. Why do we only talk about A, B, and Rh? Well, because those are the ones that create the most problem with regard to um, rejection reactions. Okay, so if this is type O, we said this one that sticks out on the side, that would be RH. So this would be O positive. O positive. It's positive because it has this RH part. Okay, this would be A negative. This would be A positive. Okay, this would be B negative. This would be B positive, as that's sticking out. And then the last one would have A and B and RH. It's got all those different things sticking out. Okay, so AB positive has A antigens and B antigens and, thumb, RH antigens. I'm not getting the screen right. Okay, so hopefully that's helpful. I don't know. I don't know about the fist and fingers symbolism, but I think it's hopefully that analogy helps you some. So AB blood groups are based on the presence or absence of two codominant antigens. A and B means you have AB. None means you have type O. If you have an allele for A from one of your parents and an allele for O from your other parent, you still have type A. And if you remember from genetics, that's something we're talking about dominance, and in this case with blood type, codominance. If they're both there, they're just both there. Okay? So if you have A and B, you just have A and B. But if you have A and nothing, you just have A. B and nothing gives you type B, or B and B gives you B. The type of antibodies carried by each blood type. Whatever you don't have, you're going to have antibodies to. You're going to react to. So if you don't have A antigens on your blood cells, then your body is going to recognize blood that does have those A antigens. It's going to attack this, hook onto this and attack it, because it doesn't recognize this because your blood doesn't have this. Okay. The reaction of concern is donor antigens versus recipient antibodies. So whatever you don't have, your body is going to recognize as being foreign. So what we're saying is the donor antigen. So if the donor's blood has A and the recipient's blood doesn't have A, this recipient's blood is in the fluid of your blood. You're going to have these antibodies that are going to attack those antigens that they don't recognize, or that they do recognize as being foreign. A transfusion reaction results in the lysing, means the bursting of foreign red blood cells. And then all of those particles of those red blood cells can cause kidney blockages as your kidneys try to filter your blood. Okay, so compatible types. O can donate to all. Since, look, anyone's blood is not going to recognize this as foreign because it doesn't have any of these parts that stick out. So it's not going to have anything. This blood being given to someone is not going to be recognized as foreign. AB can receive from all because, again, AB has RH, and it has A, and it has B. So whatever blood you give this person, the fluid around their blood is not going to have antibodies that recognize any of these things as foreign because it already has all three of them. Okay. O can only receive from O because it has anti-A and anti-B. Someone whose own blood is like this is going to recognize anything that's sticking off of new red cells as foreign. So someone who's O negative, which would be this, all they can get is O negative because they're going to have antibodies for A and B and RH. AB can only donate to AB since all the others will either have anti-A or anti-B. So AB can receive from all, but can only donate to AB. Okay. Um, this is an interesting thing, and probably if you ask your parents or your grandparents or somebody, they're going to know someone who experienced this particular condition. And I'm not very good at explaining it. It's a little hard to understand that just regular uh, blood transfusion reactions. So I'll show you this um, hemolytic disease link here in just a moment. But this is Rh blood grouping, by the way. So one of these Rh antigens was found in something called a rhesus monkey. Most people are Rh positive, so they do in fact carry that antigen. But Rh negative people don't carry the Rh antigen unless they are sensitized or exposed. Okay, or excuse me, the anti-Rh. So you're not people who don't have type A blood have anti-A, and people who don't have type B have uh, anti-B. But people who don't have Rh don't have the anti-Rh unless they've been exposed to it. So it doesn't. So that's called sensitized, and that sets up the possibility of the hemolytic disease of the newborn in Rh negative mothers. So let's take a look at this, and then we'll see if we can. Oh, well, here's the finish of it. The baby is Rh positive. Okay, so this sets up possibility of hemolytic disease of the newborn in Rh negative mothers if their baby is Rh positive, and it's prevented by the administration of a product called Rogam to block that sensitization. So I'm going to go backward and show you that link. So until they mix, the mom is not going to be sensitized. kind of an interesting thing there, where they're artificially attacking those Rh antigens, so that naturally the mother's body never really has to produce anti-Rh, and so then going forward, she wouldn't be making those. All right, and we just have a couple more screens here, or one more maybe. All right, so um, blood typing, um, tested with anti-serum to determine the antigen, therefore the blood type. So you can, if you mix the anti-serum with the blood, if that particular type of anti-serum causes a agglutination reaction, then you know that their blood has that. So if you have anti-A serum and you mix someone's blood with anti-A serum, and that anti-A serum makes an agglutination, there's a kind of a clumping, or becomes grainy looking, then you would know that their blood had A antigens. Same thing with B or whatever. So then cross matching is testing for agglutination with both donor cells and recipient serum, and donor serum and recipient cells, kind of to double check that it's going to be compatible. Okay, so I guess what I need for you to do for it'll be for next Monday, we should be finished with the questions through 39. So we're going to go questions through 39, and we'll you need to answer them, and we'll quiz on them on Monday. So make sure you've answered 1 to 39 in your study guide, and we'll quiz over those. Okay.